Hi everyone, welcome back to Array series. Hope you are doing good. This is Mahesh. In this video, we will look into Leetcode problem number 53, maximum subarray. Okay, so let us try to understand what is the problem. So here we have given an integer array nums and we need to find the subarray with the largest sum and return its sum. Okay, so they have given some inputs and they have given the constraints. The length of the nums array lies between 1 and 10 raised to 5, and also any number in the array lies between minus 10 raised to 4 to 10 raised to 4. Okay, with that, let's switch to editor. Okay, so first we will try to understand this problem in detail. So what they are saying us to find the maximum subarray sum. So what is a subarray? Subarray is basically any part of the array which contains numbers which are in their continuous order itself. So basically, and there should not be any number missing in between. You can ignore the initial few numbers and after few numbers, or you can consider the entire array. In this case, minus 2 is one subarray, minus 2 1 is another subarray, minus 2 1 3 is another subarray, minus 2 1 minus 3 4 is another subarray, and entire array can also be considered as one subarray. Okay, and also similarly 1 is another subarray, 1 minus 3 is another subarray, 1 minus 3 4 is another subarray, and it cannot be like minus 2 1 and 4, because here if you see this number is missing in this one, so this we cannot call it as a subarray. So basically the numbers should be contiguous and there should not be any number missing in between. Okay, and it can be any part of the array. It can be a single number also, and it can be the entire array also. Okay, so that is called subarray. So with that understanding, maybe you can pause for a second and you can think for any possible solution for this particular problem, and you can come back. So with that, let us also try to understand what the interviewer will be looking by giving this problem to you. So basically, so he will be expecting you to solve this particular problem in O of n time complexity and possibly O of 1 space complexity. So this can be achieved by effectively applying Kadane algorithm. So Kadane algorithm. So you need to effectively use the Kadane algorithm to achieve this particular solution with O of n and O of 1 time complexity and space complexity respectively. With that, let us try to proceed with the brute force solution for this particular problem. So what is the extreme brute force for this particular problem? So maybe what we can do, we can try to generate all the possible subarrays. Okay, let us consider another small array, maybe something like 1, 2 and 3. Okay, so what we understood the numbers should be like contiguous. There should not be any missing number in between. Okay, and if that is the case, 1 can be my one subarray, then 1 comma 2 can be my another subarray. Okay, then 1 comma 2 comma 3 can be my another subarray. With this, next I will start with 2. 2 can be one subarray, then 2 3 can be another subarray, and finally 3 can be my subarray. So with this, now how did we generate these subarrays? Basically what I did, initially I took this particular one, then what I did, I started from here, I took only this number, then I moved to next number, I took both the numbers, then I moved to the next number, then I took all the numbers. Okay, then what I did, I moved this particular point next number, then what I did, I considered this number, then I moved, then I considered this entire part. Okay, so that's how we generate the subarrays. So let us first write this pseudocode for generating the subarray. Okay, so now if you see, I need a starting point. So now I need a starting point. So this is my starting point, and I need another end point. So basically start point will be fixed initially. Then I'll move end from here to here, here to here, something like that until I have all the numbers. Then what I did, I moved start to the next number. Then again from that number I started and I moved to the next number. So that's how we try to generate the subarrays. So let us try to generate the subarrays. So what I will do, I will say for start equal to 0 and start less than n, where n is length of the nums array. Okay, then start plus plus. So this is my starting index. Okay, next another for loop I will take. I will say it is end, and its initial number or initialization would be not 0. It will start from the start index, because you saw, right? I mean, whenever we consider this number for the iteration, then we started from this number itself. Then we moved on to the next number. So then end less than n, end plus plus. Okay, so this will, these two loops, what they do, they will basically generate us the subarrays. So start will be the start index of the subarray, and end will be end index of the subarray. So if that is the case, whatever the numbers that are there between start and end index, they basically contribute to the subarray. So with that, so we knew, or from these two loops, we generated these all possible subarrays, correct, right? Now what I will do, I will try to find the sum. So for first one, it is only single number, so it is sum will be 1. For the next number, I will say 1 plus 2, then that is equal to 3. For next number, 1 plus 2 plus 3, so that is equal to 6, something like this. Okay, so now what we will do, we will write another loop. So basically we will take a variable sum and we will initialize it with 0. Then I will take another for loop, and this time I'll use I equal to, it starts from start index, which is start, and it ends at the end index less than or equal to end, then I plus plus. Then what I will do, I will say sum equal to sum plus nums of I, nums of I. So this way, what I can do with this loop, I can iterate over all the elements, basically all the elements in the subarray, then I can add them to the sum variable. Next, once after the end of this particular, this for loop, what I will say, I will take a max sum variable and I'll initialize this with minus infinity, sorry, there is a typo, minus infinity or int minimum, because that's the least possible negative number we will get, right? So with that, we can try to update this max sum. So now what I will do, I will, after this particular for loop, I will say max sum equal to max of sum comma max sum. So this way we will update the max sum. Now finally at the end, simply return max sum. Okay, so this gives us the maximum value. Basically what we did, we generated all possible subarrays, then we found the sum of each subarray, and then we took the maximum out of all the sums. Okay, this way we were able to get the maximum sum. Now what is the time complexity here? So if you see, there is this particular loop which runs for n times, this particular loop almost runs for n times, and there is this particular loop which runs almost close to n times. And if that is the case, our time complexity becomes of order n cube. our time complexity becomes of order n cube. Now what is the space complexity? We are not using anything extra. So basically that is order 1. Space complexity is order 1. So if you see order n cube, cubic equation, it's a costly algorithm. So we need to improve this. Then how to boil down this particular time complexity? Let's see. Now what we did, we generated all the subarrays using this loop and this loop. Then what we did, we again used one more loop and we iterated over the subarray, and then we found the sum. So basically what we did, initially it was 1, then next it is 1 plus 2, then it is 1 plus 2 plus 3. So what you can observe, so here this 1 is common, right? And here this 1 and 2 is common. So basically this sum and the next number will give me the next sum, and this particular sum plus this number will give me the next sum. So what I can do, I will copy this. Now what I will do, I will take a sum variable here and I'll assign it with 0. Then what I will do, this sum equal to sum plus nums of int. Okay, immediately after that what I will do, I will update my max sum equal to max of sum comma max sum. Okay, this way finally after both the for loops I will return my max sum. So if you see, using only this for loop and this for loop, we found the maximum sum. So now our time complexity boiled down to order of n square. Okay, and space complexity is still order of 1 because we are not using anything extra. So still if you see the time complexity, it is of order n square. So this is a quadratic equation. Again, this is a costly algorithm. So we might need to find another way. So we will see that later. Before that, let us try to execute this and see. Let's take a variable int max sum. Let's assign this with integer dot min underscore value. Okay, and let's take another variable n equal to nums dot length. Okay, I will use a for loop for int start equal to 0, start less than n, start plus plus. Okay, then I will take another variable sum. I'll assign this with 0 initially. Then for int end equal to start, end less than n, end plus plus. This way I will generate subarray. Then sum equal to sum plus nums of I. So after this I'll get the sum, and what I will do, I will update my max sum equal to math dot max of sum comma max sum. Finally at the end I will return max sum. Let's try to run this. It should be end. Okay, this got accepted. Now I will submit this. It gives us TLE because this is of order n square. Time code. Switch to editor. So Now, how do we improve this algorithm? Kadan's algorithm, which improves this time complexity to O of n. Let us see how to do that. So let me take the numbers. So this is our nums array. Now what I will do, I will declare again a variable max sum, and I will assign with minus infinity or int min. Int min, so minimum possible value. Next, what I will do, I will take one more variable sum, let it be initialized with 0. Now what I will do, I will iterate over the array only once, and I'll keep on adding the number to this sum, and I will keep on updating the max sum. Okay, let's see that. Now what I will do, our first number is -1. So sum plus -2, sum plus -2, sum is 0, 0 plus -2 is -2. So this becomes -2. Now our maximum sum gets updated with, I'll remove this -2 because -2 is greater than our minus infinity or int minimum value. Okay. Now if you see, our sum is -2, right? Now if you take the next number, which is 1 here, if this was +2, then our sum would have been increased to 3. But now it is not +2, it is -2. So our sum becomes -1. So this is not really contributing to the maximum sum, correct, right? So in that case, if our sum, whenever it goes below 0, what we will do, we will simply reset it to 0. Okay, that's what I'm trying to do here. Now let us consider the next number, which is 1. So I will add 1 to it, so it becomes 1 now. Sum is 1 now, so it is greater than maximum sum, which is -2. So I'll update this with 1. Okay, next I'll move to next number. Now if I add this to 1, this becomes -2 now. Okay, so -2 is not greater than 1, so my maximum sum remains as it is. Next I'll go to the next number, but before that, since it is negative number, what I will do, I will reset it to 0. So I'll remove this, I'll reset it to 0. Okay, then I will take this number, I will add it. Now it becomes 4. So what I will do, I will update my max sum as it is greater than 1. Okay, next -1. So -1 will be 3. So it is less than maximum, so I won't update. Next I'll go to next number, which is 2. Then it becomes 5. So 5 is greater than my current max, so I will update this with 5. Next I'll go to next number, +1. My max sum again is 6, which is greater than the current max sum, so I will update to 6. Next I will go to -5, so it becomes 1. I'll write it here. So 1 is less than 6, so no need to update. Next I'll go to next number, it becomes 5. Again this is less than our 6. So if you see, we get the maximum sum, right, which is 6. So we can simply return that answer. So this way we can find the maximum sum of the subarray in order of n time complexity. If you see, we iterated over this particular array only once, and with that one iteration we found the maximum sum. Let us try to write the pseudocode for this. So what I will do, my max sum equal to minus infinity or int minimum. Okay, then I will use for I equal to 0, I less than n, n is length of nums array, then I plus plus. Okay, I will also take another variable sum. I'll assign it with 0 initially. Okay, so now what I will do, inside I will simply say sum equal to sum plus nums of I. After this, I will check if sum is greater than max sum, then what I will do, our max sum will be updated with sum. Okay, then at the end I will also make sure if sum is less than 0, then I will reset it to 0. Okay, then at the end I will simply return my max sum. Okay, so this way we can find the maximum sum of subarray in O of n time complexity and O of 1 space complexity. This is called Kadan's algorithm. This is called, this is using Kadan's algorithm. Okay, let's execute and see that. I will comment this part. Now I will use for loop for int I equal to 0, I less than n, I plus plus. Then what I will do, before this I will also take one more variable sum equal to 0. I will say sum equal to sum plus nums of I. Okay, then I will update my max sum. I will check if sum is greater than max sum. What I will do, max sum will be updated with my current sum. After this, I will also check if my sum is in case less than 0, then I will have to reset my sum to 0. Okay, so at the end I will have to return max sum. Let's run this. This got accepted. This solution got submitted successfully. So there will be a follow-up question after this. Instead of maximum sum, they want the subarray which gives the maximum sum. Okay, so in this case we have already seen this particular array gives us the maximum sum. So if that is the case, how to find or how to get that particular array, subarray which gives the maximum sum? So what we were doing, whenever our sum was going below 0, that time what we used to do, we used to reset it back to 0. What that means? It means there is a fresh subarray that is going to start at that particular point from the next index. So we will consider this point, and what we will do, we will little bit update our code. What we will say, we will take a normal current start equal to 0. Then we will take start index equal to -1 and end index equal to -1. So what the start index and end index are used? They are used to find the start index and end index of a subarray which gives the maximum sum. So now what we will do, we will use this particular condition. We will check before processing. We will check if the sum is equal to 0. Then we will simply update our start index. It means the subarray is going to start freshly at that particular point. Now with that, now whenever we find our maximum sum, we will update start index equal to our current start, and end index will be this particular I, because that's where we found the maximum sum, right? This way we will get the start index and end index of the maximum sum of the subarray which gives the maximum sum. And instead of returning, what you can return, you can either return the start index array of start index comma end index, or you can return the elements from start index to end index. You can try this yourself. Maybe you can consider that as a homework, and you can add the comment. That's it for this video. Hope you liked the explanation. If that is the case, please consider subscribing to my channel, and also like the video, share it with your friends, and you will get a lot more such videos in the upcoming days. Thanks for watching the video.